and then ultimately to Stack Overflow site. But there's a lot more information that we can get just by looking at this trace route. For example here, you're going to notice that when we get to Hurricane Electric, they're very kind, and they label things properly. So I can see that my packets went through Ashburn, Chicago, Denver, Seattle, and then Portland before they made it over to Peak's servers. Okay, that's kind of cool. I can also see this. When I entered Hurricane Electric's network, they went ahead and upgraded me from gigabit to 10 gigabit for the trip across the country. And then when I made it to the other side of the country, they downgraded me from 10 gig back down to gigabit Ethernet. So, but the most important thing, what I really wanted to show here is as you use the -A flag in traceroute, you're going to notice that it puts the AS number before it shows you the actual hop information. So you'll see that the AS has changed 3 times, right? So you can see Cox's AS, you can see Hurricane Electric's AS number, and you can see Peak's AS number. So this path through these 3 different autonomous systems is called an AS path because it's the path that the packets took. So in this case specifically, here are the numbers, and there are the businesses. So our diagram again looks like this with the real numbers now. And you can start to put together some real-world scenarios. So at internet scale, of course, we're not routing individual or DevIgnition, right? For that matter. At internet scale, the protocol that the ASs use to communicate with each other is called Border Gateway Protocol, or BGP. And you don't, the internet's big, right? There's lots of IP addresses, 4.3 billion in V4. You can't load all of those in the routers because every router has all the AS paths, right? So there's about 40,000 ASs on the internet.